Greetings. This is our first lesson on quadratic functions and their transformations. This is lesson 4.1. We're going to do it in two parts, 4.1a, and then we will do 4.1b. All right, so I'm not going to take the time to go over that since we have a shortened time. A parabola is the graph of a quadratic function, which you can write in the form y equals ax squared plus bx plus c. So the big thing to see here is a quadratic happens when the largest exponent is 2. The parent function of a quadratic looks like this. A parent function is the most basic function. So f of x, which remember is just the same thing as y, equals x squared is the parabola. That shape there is called a parabola. The axis of symmetry would be x equals 0. The vertex there is 0, 0. So that's the most basic form of a quadratic called the parent function. So we can see graphing it here. So the points that you would get from that, right, if you plug in 0, 0 squared is 0. So you have the point 0, 0. 1 squared would be 1. So you have the point 1, 1. 2 squared would be 4. So we have the point 2, 4. Then we could even go 3 squared is 9, so we have the point 3, 9. Oops, I went to 10. So then, remember the axis of symmetry is at x equals 0, which would be this vertical line here where x is 0. So we could reflect these points across and then graph our parabola. Right? Because we could also know then that if we plugged in -1 squared is 1, -2 squared is 4. So you can see that those points do reflect across x equals 0. All right, the vertex form of a quadratic function is, and you'll use this a lot, y equals a times x minus h quantity squared plus k. The axis of symmetry is x equals h. So now the parabola is leaving the vertex of 0, 0. And the vertex is hk. So you would just pick the h and the k out of vertex form. So like here, the graph y equals x minus 3 quantity squared plus 3. So remember your transformations, right? Your transformations. And Max said that he said this too, which he stole from me, which I stole from someone else. Remember the inside lies. So on the inside, when you add, the graph goes to the left. When you subtract, the graph goes to the right. It sounds backwards because the inside lies. The outside does not lie. So on the outside, when you add, the graph goes up. When you subtract, the graph goes down. So like looking here, I subtract 3 on the inside. The inside lies, so I know that's going to send me right 3, the vertex. Then when I add 2 on the outside, I know it's going to take me up 2, right? So that vertex, which is usually in the parent at 0, 0, I'm going right 3, 1, 2, 3, up 2, 1, 2. So the vertex is right there at 3, 2. Then this has a normal width. We haven't gotten to that yet. So those points I could plug in, right? From here now, if I go right 1 squared is 1. So right 1, up 1. 2 squared is 4. So if I go right 2, I go up 4. And then I can reflect those points across, right? The axis of symmetry always goes through the vertex there. So then I can reflect those points to the other side and make my parabola. Right? The other way you could do that is if you made a table, you knew your vertex was going to be at 3, right? It was going to be, because you went right 3 up 2. You could plug in the points, you would plug in 3, you would get out 2. So then you could go to the left or to the right of that. You could go to the right. If you plug in 4, you get out 3. Graph it. You plug in 5, you get out 6. And then you could graph it. All right, something else to look at. A is going to tell you if your graph opens up or if it opens down. So if A is greater than 0, that means your graph is going to open up, right? If your graph opens up, it has a minimum value because it bottoms out here. It's not going to have a max. because it goes up forever. Where if A is less than 0, right, your graph is going to open down. If your graph opens down, then it has a maximum value, right? It has a top of a mountain, but it's not going to have a minimum value because it's going to keep going down forever, right? So that A being positive or negative tells you if it opens up or down. All right, so here we're going to start picking out the pieces, and then in a little bit here we are going to graph. So you can see this is in vertex form. Y equals A times X minus H, quantity squared plus K. So remember the vertex is HK. Axis of symmetry is X equals H. I was going to write axis of symmetry, but it's already written. X equals H. Minimum or maximum has to do with A is positive or negative. All right, so we can see here. We can line them up. H is 4, K is -2. So remember, the inside lies there. So the vertex HK is 4, -2. Axis of symmetry is an equation, always X equals, because it's a vertical line. So it's X equals H is 4. To figure out the minimum or maximum value, well, let's see here. A is 3, so A is positive. Since A is positive, it opens up. Opening up means that there's a minimum value. And you can always tell what the minimum value is based on your Y coordinate here, right? It would be -2, because the furthest that this is going to go down, because there's a minimum, would be -2. I'll go over here for the domain and range. So the domain, remember, is the X is being used. The range is the Y is being used. So for a parabola that opens up or down, right, that means it's going to go to the left forever and it's going to go to the right forever. So the domain of a parabola that opens up or down is always going to be all real numbers. The range is the Y's that are being used, right? So Y, well, we know it has something to do with -2. Well, the minimum here was -2. The furthest this goes down was -2, and then it goes up forever. So the Y's are greater than or equal to -2, because it goes from -2 to infinity, right? On that parabola, the furthest it went down was -2, and then it went up forever. Now, weird on Math Excel, they're going to have you type this in as all real numbers greater than or equal to -2. In this section, that's how Math Excel types it. Just FYI when you're working on that. All right, so picking it apart, vertex, inside lies. So it'd be -3, 4 for our vertex. Axis of symmetry, X equals H is -3. A is -2, which is negative, so it's opening down. So that means there's a max. The maximum value would be 4, because it's always your Y coordinate there. The domain, how far left, how far right, is always going to be all real numbers, because the parabola goes to the left forever, and it goes to the right forever. And then the range is the Y's, how far down to how far up. So it has something to do with Y, and the maximum value was 4, so it would be less than or equal to, because here our maximum value is 4, and then it goes down forever. So the Y's are less than or equal to 4. So now we're going to start to graph it here, right? We're going to start to make some graphs. So let's talk about our transformations that we talked about here. Subtracting 2 on the inside lies. That's going to take it right 2. And then when we subtract 5 on the outside, that's going to take us down 5. So this goes right 2, down 5. That's where our vertex would be, right? That's where our vertex would be. Since A is negative, we know that it's going to open down. So then to get your other points, right, we also know then that our axis of symmetry goes through our vertex. We can follow the pattern. Since A is an invisible -1, the width is the same. So we know that if we go 1 to the right, 1 squared is 1. So we can go 1, 1, dot. We know that 2 squared is 4. So we can go right 2, down 1, 2, 3, 4. And then as always, we could just reflect those points over. Right? Or if you wanted to do values, right, you know that your vertex was at 2, -5. So then either go to the left or to the right. I'm going to go to the left this time because they're still pretty numbers. When I plug in 1, I get -6. Then I can reflect it to the other side. If I plug in 0, I get -9, and then I can reflect that to the other side. All right, so when it gets a little tricky to just do transformations is when your A value changes there. So let's look at this. So graph, well, subtracting 1 on the inside lies, so we know this is going to go right 1. Add 4 on the outside, we know it's going to go up 4. So our vertex moves right 1, up 1, 2, 3, 4. We know our axis of symmetry, the line that cuts it in half, is going right through there. I lost my dot, there it is. So now to get more points, we know that A is positive, so it's going to open up, but it's also going to stretch by a factor of 2. Remember that A value is what makes it stretch and compress. It can make your parabola really skinny, or it can make it really wide. So this one is by a factor of 2. So let me try and explain this. So usually we know that if we plug in 1, right, we get out 1 if we're just in x squared. So that's why we would always go right 1, up 1. But now you're changing that by a multiple of 2. So I'd go right 1, up 2. So then when we plug in 2, 2 squared is usually 4. But now we're stretching by a factor of 2. So 4 times 2 is 8, right? So we would take this right 2 from the vertex, up 1, 2, 3, 4, 5, 6, 7, off the chart. So then we can reflect those to the other side and make our parabola. And you can kind of tell it was only a stretch of 2, so he's a little bit skinnier, but not a lot of it skinnier. So that's because there was a stretch of 2. So you take those normal parent points of 1, 1, 2, 4, 3, 9, and you would multiply that y value by 2 for the stretch factor. Again, if that's confusing for you, you don't like that part, you can also just do the points, right? Pluggy chuggy. So you knew x, y, that your vertex was going to be at 1, 4. So then knowing that, you could pick points on either side of 1. I'm going to go to the right this time. So if I plugged in 2, I got 6. Plot it, reflect it. If I plug in 3, I get 12. Plot it, reflect it. And when I say plug in, I'm saying plug x into the equation that you were given. All right, and that is just an introduction on quadratic functions and vertex form. We will do a lot with this chapter and how to graph them.